So now that we've got this connection between area under a curve and distance traveled by a car, they're going to ignore that connection for the first few homework problems and just focus on area. So let's take a look at number 4 from your homework. It's not an assigned problem, but it's similar to 3 and 5, which you will be doing. So number 4 says, let's talk about the function 25 minus x squared from 0 to 5. So let's get that function. It looks like this, and they are interested in going from 0 to 5, which kind of makes sense considering what the curve looks like. And they have specific language for us. They say use 5 rectangles and write endpoints. So first of all, we need to split this up into 5 rectangles, and nicely enough, that matches the units. So we'll have a rectangle there, 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 and there. And we're going to have the vertical edges of the rectangles will be based on those points. So I'll just go ahead and sketch those in. You can tell I'm still new to the drawing tablet. I have a hard time drawing straight. Let's see, let's get one of these right here. Yikes, pretend that's a straight line. Okay, so they want us to use these as rectangles, and the language of using right endpoints, I'm drawing in the bottoms here, trying to. See, the language of using right endpoints tells you where they want you to put the tops on these rectangles. So this first rectangle here between 0 and 1, as we go up here, I'm going to look at the top, and deciding the height, where the top of the rectangle will go, I'll look right here at the right hand side of the rectangle, and I'll say, okay, right there it's at a height of 24, so I guess that's where I'm going to top that one off. And the second one, I will also, over the second rectangle, look at the right hand side of it, and where the right edge of the rectangle hits the curve will be my top, and put a top on there, and one on there, and this one actually has one right there, so that last rectangle has an area of 0. But now we'll just go through and figure out the areas of each one of these rectangles. They are all 1 by something, right? Because the base of each one of those is exactly 1 unit. But the first one's a 1 by 24, it looks like. So it's an area of 24. And the next one's a 1 by, what is this, 21. And this is a 1 by 16. And a 1 by 9. And the last one doesn't even look like a rectangle, but it's a 1 by a height of 0, technically. So those are the 5 rectangles that we're adding up to try to approximate the area under this curve, which we know does have a connection to distance if this curve represented velocity. So adding up the areas of those 5 rectangles, let's see, is 24 plus 21 is 45, and 16, 55, 61, 70, and 0. So this is with what they call right-hand rectangles. Our approximate area 70. Part B says to go ahead and do that same thing again, but use the left side of each rectangle. So let's clear out those right-hand rectangles, and let's do this again, maybe in a different color. And let's say with left-hand rectangles, we still want 5 of them, so we're still putting our marks in the same points. So we'll still draw the sides of our rectangles the same way. In these spots. And if we didn't have a graph, by the way, we'd just be evaluating the function. So f of 3 would give us 16, so we'd know that value if we weren't looking at the graph. And 5. Okay, so this time the only difference is that when we figure out where to draw the top of the rectangle, we're going to for this first hour or first unit, we're going to the left-hand side and saying, where does that hit the function? So it goes right there. And over the second hour, or second unit, the left side of that, so to top that rectangle off, goes right there. Notice last time all of our rectangles were too short. They were underestimates, and this time they're all going to be too tall. They're all going to be overestimates. But we can go through and draw in each of these rectangles. So these 5 rectangles now are what we're trying to shade and figure out the areas of for the left-hand rectangles. And I won't write the actual one. Maybe I will. It's good practice to always keep in mind that the base of this rectangle might not be 1 every time, depending on how many rectangles we want. So this first rectangle here is a 1 by 25. So it has an area of 25, and this is a 1 by, what, 24? And this is a 1 by 21. This is a 1 by 16. And this is a 1 by 9. So when we add all these up and we get our left hand rectangle approximation, let's see, that's going to be 25 and 24 is 49, 70, 86, 95. Okay. So that's the idea behind using either left hand or right hand rectangles. And if I turn the right hand rectangles back on, you'll notice that there's this symmetry here, that this 1 by 9, the green one, matched the previous red 1 by 9. So there's a lot of repetition between our two calculations, the right hand and the left hand. And as we go a little bit further, we'll do things like average the two to try and get even more accurate. Anyway, that's all that we need to do for this particular problem.